Hello my dear students, good afternoon. Now we will discuss about Fajan's rules which gives information about the compounds who have covalent character, who have ionic character like that, who have more ionic character, who have less ionic character like that. So as I said in previous class, we had polarizing power concept. Polarizing power means what? Polarizability, I said for anion. Polarizing power means the ability of cation to attract the negative charge on anion. Polarizing power is more than what I said, covalent character is more. When the polarizing power is more, when the positive charge or negative charge is more. So it's very simple. Okay, so we have to discuss about now Fajan's rule. Okay, and similar story. Factors favorable we discussed. Cation with smaller charge and cations with larger charge. Okay, who have ability to form ionic bond easily? I said cation with large size. Those things only here we will discuss. Okay, so what that smaller cations and larger anions. Smaller cations and larger anions forms covalent compounds. Forms what? Covalent compounds like that. Okay, so smaller cation and large anion forms covalent compounds. And the second one, ulta, large cations and small anions forms more ionic compounds. So smaller cations, if you see now, if you say LIF, okay, and LIF, and suppose now with the smaller cations, I'm saying LIF, and now NAF and KF. What is this? KF and RBF and CSF. So smaller the cation. Here who is the cation? Li plus. And here who is the cation? Na plus, K plus, Rb plus and CS plus. So what is the cation size? Cation size is this order. So therefore larger cation can easily form more ionic. The smaller this is now covalent now. Of course ionic only, but covalent character is more. It is not completely covalent compound, I am not saying. Covalent character, sharing nature is more. Okay, smaller ions will have more polarizing power. I forgot to say, I think so. Size of cation, if small, then polarizing power is more. This is also important. So LIF has covalent character, but ionic compound only, but sharing nature is there somewhat. But ionic nature in this way. So this CSF is more ionic. So order of ionic nature means this one. So first point and this second point, larger the cation and smaller the anion forms more ionic compound. Understanding? So as I mentioned in factors favorable, those only here also. Okay, no other things we are discussing here. Okay, so nothing new here. These all things you know already. So which can form easily means I am saying, that's it. Okay, same manner, if anion size is increasing, so somewhat with another like MgF2, MgCl2 and Mg, okay, MgBr2 and MgI2. So which anion can easily form? Means F minus can easily form, you know that already. So with magnesium, smaller fluorine. So this is about ionic character. Because here what happened? Iodine is large. So MgI2, larger anion means covalent character. Larger anion, covalent character. With anion I am saying. Okay. So cation is similar here, but anion is large, but here anion is small. So both the points, but don't worry about examples. Here, this example better to write here. So just consider the things here. Larger anion, okay, covalent. Smaller anion, like that. Larger cation, different cation I was not given. Here I was given different cation. Here different anion I am giving. Same cation. So here anion is similar. So with respect to cation we will say. Here cation is same. Now with respect to anion we are saying. So smaller anion. So fluorine is small. So covalent character. Sorry. This is ionic character. Ionic character is more for this MgF2. Covalent character means here. This is iodine is large. So here fluorine is small. But here iodine is large. So this Mgi2 has somewhat covalent character like that. So in that way we will say. Understand? So two things. And third one. Okay. So if cation and anion, if cation and anion have inert gas configuration, then they have ionic character. What character? Ionic character. Okay. Suppose, very simple, see this. MgCl2 and ZnCl2. Which is more ionic now? MgCl2 is more ionic. So if cation and anion have inert gas configuration, then they have ionic character. So here anion is same. So with respect to cation we have to say cation here Mg2 plus and there is Zn2 plus. So this has inert gas configuration. This Zn2 plus has pseudo inert gas configuration. So which cation is more stable? Mg2 plus. So magnesium forms ionic compound and Zn2 plus also ionic but slightly covalent character. So MgCl2 has ionic character and ZnCl2 has somewhat covalent character. Of course Zn2 plus and 2Cl minus only, but little bit of sharing nature is more. That's what I am saying. So here one more important thing I said, if cation and anion have inert gas configuration, then they have ionic character. Understood, sir? Please note it down first, this point and this point and this point. Got it, sir? So here one important thing I said, why MgCl2 is ionic, why ZnCl2 has somewhat covalent, means here both have inert gas configuration, but here anion is inert, okay, but cation is not having inert gas configuration and Zn2 plus has pseudo inert gas configuration. So Zn2 plus has a bit covalent character and MgCl2 has completely ionic character. Understood, sir? Okay, so even ionic they have attraction, sir. So that's why little bit of sharing nature we are saying. So please write it down all these things. Now we have to discuss last and final point in Fajan's rules. Okay, how many we discussed now? How many? 3 points we discussed. What is that? Cation size if small and anion size if large, then what happen? They have a covalent character. So to form more ionic, so what I said, cation size should be large and anion size should be small. And last and final, if what? If cation or anion, as I mentioned in previous already, from polarizing power also I am saying positive charge is more, then polarizing power is more, so that covalent. That point only I will give you here. Cation charge is less or anion charge is less. Certainly they are ionic. That point only I am giving here. Okay. If cation or anion have small charge, then those compounds have have what? Ionic character. Okay. As I mentioned, suppose here LiCl and BeCl2, and here like that. If you see, yeah, among these, who has more ionic? Means charge we have to see Li plus and Be2 plus, or even anions like that. Okay, suppose anion is different. NaCl and here somewhat different. I will AlCl3 and Al2O3 like that, or something like different. Aln. Okay. Who is more here? See, with respect to aluminum, we can't say like Cl minus and N minus 3. So anion's charge is more. So certainly covalent. Ionic means this one. Understanding? So if cation or anion have a small charge, then this one. But ionic means among these AlCl3 and Aln, LCl3 is more. As I mentioned many times, like NaCl and MgO and Aln. So who is more ionic? Previous also I was given this example. Why NaCl has more ionic? Because smaller the charge, then they have ionic. Larger the charge, then covalent. So NaCl has ionic character. Sorry, NaCl has what nature? Ionic nature. This Aln has covalent nature. Why? What is the reason? Na plus here, Cl minus here. But whereas here, Al plus 3 and N minus 3. What you are understanding here? So cation and anion size if small, then ionic character. Simple. NaCl, cation and anion have smaller charge, then ionic. Cation and anion have larger charge, means big charge, more positive and more negative, then covalent. So here, who is more ionic? This one. Why LiCl is more ionic than MgCl2? Here Li plus, smaller the positive charge, and Be2 plus, positive charge is more comparatively this. So LiCl is more ionic, so BeCl2 has somewhat covalent comparatively. Got it, sir, clearly? So fourth point, opposite, I have no need to say, I think so. If here A is like this, if cation and anion have small charge, then those compounds have ionic, I said. B, another statement. What you can give? If cation and or anion, anything else at least. Comparison we have to see, that's it. Understanding? So no need to by heart. Simply we have to observe the options what they given. Okay? So if cation and anion or else otherwise. Okay? Cation or anion have large charge. Large charge means what is the meaning? More positive charge, more negative charge. Large charge. Then those compounds are covalent in nature. So here you have examples. Here NaCl, MgO, Aln. NaCl is more ionic, but Aln is more covalent. What is the reason? Here charge is more. Okay? Understand, charge more means how you have to say? More positive charge or more negative charge? So -1, no, -2, -3 means -3 more charge, like that, not numbers. Okay? So like that we have to consider Fajan's rules. Total 4 we discussed. Please write it down. Here cation and anion have small charge. So when ionic character is more, please tell me. So examples you written everyone. When ionic character will be more. Cation size must be big. Anion size must be small. Cation or anion must be inert gas configuration. Or fourth point, cation or anion must have small charge, then ionic. Understood, sir? Please write down all these things. Then we will discuss the most important topic here. Okay? So we will say one more important What is lattice energy? See, the amount of energy which is required to break 1 mole of crystal lattice. Okay, 1 mole of unit cell. So, to understand this lattice energy, one by one we have to understand. One is crystal lattice. What is that? Crystal lattice. What is meaning of crystal lattice? Crystal lattice means the cubic arrangement of atoms or ions in regular manner. Cubic, you know, no, cuboid, you will plane or like that. So like that ionic compounds exist. Ionic compounds exist as solids in the form of crystal lattice. Crystalline solid or crystal lattice means the regular arrangement of atoms or ions in a cubic manner or three-dimensional manner is called cubic lattice. This cubic lattice has a unit cell. Unit cell means the regular part of a crystal lattice which repeats regularly is called unit cell. This is a unit cell. These are the ions. These are what? Ions like. This is called unit cell now. These unit cells will repeat regularly. Means here one, here one, here one, upside and bottom side like that. So the repeating part of the crystal lattice the repeating portion of a crystal lattice is called unit cell. Understanding? Here you have ions maybe. Here if you have Na plus, here Cl minus opposite. Again here Na plus, here Cl minus like that. Positive ion, negative ion, positive ion, negative ion. And like that we have. Okay, here negative ion, here positive like that. Understanding what I am saying? So the positive ions and negative ions regularly repeated in a unit cell. So what is unit cell? The small portion which repeats regularly. Suppose in a building you have small rooms. Those rooms will repeat. So each repeated room is called unit cell. And all rooms are identical. Like that unit cells will repeat. Understanding? 1 mole of crystal lattice means Avogadro number of unit cells they will have. Because 1 mole means what is the meaning? 1 mole means what is the meaning? Avogadro number or not? What is Avogadro number? 6.023 and into 10 power 23. Do you know the meaning of 1 mole? So 1 mole of unit cells, suppose I said, that means 6.023 into 10 power 23 unit cells are present in 1 mole of crystal lattice. 1 mole of unit cells present in 6.023 into 10 power 23 unit cells present. So first I said what is lattice energy. So to understand lattice energy you must know what is crystal lattice, what is unit cell. Hope you understood what is unit cell. Now what is lattice energy? I repeat one more time. The amount of energy which is required to break the 1 mole of crystal lattice is called lattice energy. Otherwise, the amount of energy released when 1 mole of crystal lattice formed is called lattice energy. What is lattice energy? The amount of energy, suppose released when 1 mole of crystal lattice or 1 mole of unit cell formed. Okay, unit cell. 1 mole of unit cell. 1 mole of unit cell formed. So what we are discussing now? Structure of ionic compound. How ionic compound exists in a regular manner like this. Ionic compounds exist in crystal lattice. Crystal lattice is like a building. Unit cells are rooms. Understanding? So unit cell is some identical repeated portion in a crystal lattice. Got it? So what is lattice energy? The amount of energy released when 1 mole of unit cell formed, or else the amount of energy required to break the 1 mole of crystal lattice, or 1 mole of, so lattice energy we will say for unit cell, per unit cell we can calculate. Okay, so the amount of energy which is required to break the 1 mole of unit cell of a particular crystal lattice. Understood? So what we discussed means lattice energy definition, crystal lattice definition, unit cell definition. What is unit cell? The smallest portion, I have write unit cell means, you also write down the amount of energy released, I said no, required to break the 1 mole of unit cell also write down. Okay, so that is one. And unit cell means the smallest portion, in unit cell, in crystal lattice, in what? Crystal lattice which repeat regularly. Understood? Is called unit cell. Unit cell, 1 mole of unit cells means how many? 6.023 into 10 power 23. So next, how to calculate lattice energy. We have to understand. Okay, so to understand calculation of lattice energy, we must know one important thing, that is Hess law of heat summation. Hess law of heat summation, which is very, very important for us. Very, very important. Hess law of heat summation. So if you understand, it's useful in thermodynamics also. Okay, so let's see what is Hess law of heat summation. Why we are discussing this without logic, are you thinking? No. To calculate lattice energy, we will use Born-Haber cycle. That I will explain maybe next class. Okay, so to understand that Born-Haber cycle, you must know what is Hess law. Why we will use this to calculate lattice energy? One process was given, Born-Haber cycle. In that Born-Haber cycle, we will use this Hess law of heat summation. Okay, so according to Hess law, the amount of heat liberated means released, or what? Absorbed. It will be remains same. That will be remains same whether the process takes place in a single step or multiple steps. Is called, what that is called? Is that called Hess law of heat summation. I repeat, the amount of, according to Hess law, the amount of heat liberated or absorbed, it will be remain same whether the process takes place in a single step or multiple steps. Because a process is taking place, reaction taking place. There are two ways. One is a direct step process, one is a stepwise process. Understanding? Suppose 5 fruits somebody given to you. One will do all 5 fruits they'll eat one time. That is single step mechanism. Another fellow will take 5 fruits and stepwise, one by one fruit they will eat. But what they said? So what energy you will get in a single step and what energy you will get in a multiple step remains same, he is saying, Hess law. Got it what I said? What the amount of energy you will get, it will be remain same if you eat all 5 sweets or fruits in a single step, or one by one you ate 5 times. Both will be same, he said. So first definition I will write. So What is that? According to Hess law. Okay, here the amount of heat liberated means, what is the meaning? Released, liberated or absorbed. Amount of heat liberated or absorbed, very important. In thermodynamics also we use this. Okay, the amount of heat liberated or absorbed will be remains constant. Okay, what? Whether the, okay, if the process takes place in single step or in multiple steps. Okay, first I will give example like that. Single step I will give. Single step means A gives rise to D is a single step. Here the amount of energy released, delta H single step, is equals to S. S means single, is capital Q. Heat released or absorbed is Q. And now multiple steps involved in a reaction. What are the multiple reaction steps? Step 1, A gives rise to B. Now delta H1 is Q1. Second means from B, B gives rise to C. Delta H2 is Q2. Okay, delta H means what? Enthalpy. I told no, ionization potential. Not true. Delta H IP, delta H EZ, electron gain, enthalpy, like that one. Delta H means heat, change in enthalpy. H means enthalpy, delta H means change in enthalpy. Okay, electron gain enthalpy I was given, delta H EZ, like that. Delta H positive, endo, delta H negative. Negative means heat release, like that I was given, no? Yes, that only. Now third step is C gives rise to D. So delta H3 is some Q3 now. So these are the multiple steps and single step. A gives rise to D. This much of amount of energy released or absorbed, whatever. Okay, that depends on the process. Now what we will say according to Hess law. According to Hess law now, delta H is equals to delta H1 plus delta H2 plus delta H3, because the amount of heat liberated or absorbed will be remains constant if the process takes place in single step or multiple steps. That means what Hess law said, the energy in single step, simple in our language, energy in single step is equals to sum of the energies of multiple steps. That's it. Single step energy is equals to sum of the energies of multiple. That only na meaning. Sum of the energies of multiple steps. Energy remains constant whether the process takes place in a single step or multiple steps, means what is the meaning? Single step energy is equal to multiple steps energy. That is all. That is what he given according to Hess law. So what we can say according to Hess law now, therefore capital Q is equals to Q1 plus Q2 plus and Q3. So by using this, and tomorrow we will do one important thing, that is Hess law of heat summation. Hess law of heat summation. Understood, sir? By using this Hess law of heat summation, we will calculate lattice energy by using Bohr-Haber cycle. Thank you. So tomorrow we will continue, in our next class we will continue that calculation of lattice energy. So what is lattice energy? What is crystal lattice? What is unit cell? And what is Hess law? We discussed along with Fajan's law.